Husky Pressure Vacuum, or PV vents, utilize 3 separate valves to control overpressure and vacuum conditions that arise in storage tanks.
When installed properly, the Husky PV vent can manage the positive and negative pressures in the underground storage tank, along with emergency venting. The Husky PV vent was designed to meet the positive and negative cracking pressures and leak rates set by the latest CARB specification to minimize vapor exposure and emissions. The emergency venting feature was added to handle abnormal fuel deliveries.
For guidance on the installation process, please refer to the detailed instructions provided with the PV vent. Remove the pressure vacuum PV vent from the carton and visually inspect for any shipping damage. Shake the PV vent gently to determine whether there are any broken parts that are not visible. Shipping damage would include loose components in the carton or noticeable dents in the housing or rain hat. Do not touch the internal components. If you're concerned about shipping damage, perform the California Air Resources Board CARB TP-201.1E bench test before installing. Here we have the PV vent bench tester, which is connected to a digital manometer and a bottle of regulated nitrogen set between 4 and 5 pounds per square inch. With the testing equipment in place, we follow the procedure provided by the manufacturer of the PV vent tester, which is based on the CARB TP-201.1E procedure. After checking the test equipment for leaks, we install our PV vent on the tester and begin each test.
The first step is the positive leak rate test. Our first step is to close the left rotometer control valve. Second, we close the bypass valve on the back of the tester. Third, we make sure we are connected to the regulated nitrogen supply. Fourth, we turn the nitrogen supply valve to pressure. Fifth, we turn the test valve to pressure. Sixth, slowly open the control valve on the positive flow metering device until the pressure stabilizes at the positive leak rate pressure of 2 inches of water column as defined by CARB. Now we maintain steady state pressure by using the control valve. Now record the positive leak rate and close the control valve. The leak rate should be no more than 0.05 cubic feet per hour for the Husky PV vent. The second test is the positive cracking pressure test. Our first step to begin this test is to open the bypass valve to route the flow outside the PV vent test assembly. Second, we open the left rotometer control valve to establish a flow rate of 0.25 cubic feet per hour. Third, once the flow rate is established, we close the bypass valve to route the flow into the PV vent test assembly. Fourth, we observe the positive pressure once it stabilizes. Now, record the stabilized cracking pressure. The final cracking pressure should be between plus 2.5 to plus 6.0 inches of water column for the Husky PV vent. The third test is the negative leak rate test. Our first step is to close the right rotometer control valve. Second, we close the bypass valve on the back of the tester. Third, we turn the nitrogen supply valve to vacuum. Fourth, we turn the test valve to vacuum. Fifth, we slowly open the control valve on the negative flow metering device until the pressure stabilizes at the leak rate pressure of minus 4.0 inches water column as defined by CARB. Now, if you're unable to reach the minus 4.0 inches of water column with the control valve completely open, then partially close this control valve and slightly increase the outlet pressure on the nitrogen regulator, and then open the control valve. Maintain steady state vacuum by using the control valve. Now record the negative leak rate and close the control valve. The leak rate should be no more than 0.21 cubic feet per hour for the Husky PV vent. The fourth test is the negative cracking pressure test. First step to begin this test is to open the bypass valve to route the flow outside the PV vent test assembly. Second, we open the right rotometer control valve to establish a flow rate of 0.42 cubic feet per hour. Third, once the flow rate is established, we close the bypass valve to route the flow into the PV vent test assembly. Fourth, we observe the negative pressure once it stabilizes. You may need to readjust the rotometer control valve to maintain the 0.42 cubic feet per hour. Next, record the stabilized cracking pressure. The final cracking pressure should be between -6 and -10 inches of water column for the Husky PV vent. Now that we know the PV vent is operating properly, we remove the PV vent from the bench tester and gather all the other tools needed to install the PV vent on the vent stack. The tools we will need to install the PV vent include a wire brush, some Gasola thread sealant, a 1 1/8 inch socket and a ratchet, a torque wrench, and a shop towel. To keep items from falling from the lift, we place all of our tools and the PV vent into a bucket. Now we are ready with the tested PV vent and our bucket of tools. In this application, with the vent stack located several feet above the ground, we use a lift to allow the installation to comply with U.S. safety regulations. We place our tested PV vent and bucket of tools on the lift, position the lift near the vent stack, and raise the lift to the vent stack height. This allows us to bring the PV vent to the top of the vent stack without tossing it or touching the internal components. Remove the old PV vent and set it aside. Using a wire brush or similar tool to remove all the debris from the vent stack. Next, apply a fuel-resistant pipe sealant, not Teflon tape, to the threads on the 2-inch vent stack. We recommend the thread sealing compound Gasola soft set or an equivalent that is UL classified. Next, we screw the PV vent onto the vent stack by hand. Now tighten firmly with a 1 1/8 inch wrench using the hex fitting on the top of the vent with approximately 20 to 50 foot-pounds of torque, but do not over tighten. And finally, we clean the residual thread sealant from the vent stack threads with the shop towel. Please refer to the installation instructions that came with your Husky PV vent if you have any additional questions.